Test, 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 test. Hello. Good afternoon or good morning. Long time no see. Alright, here's the plan. And I guess I can show the plan. Step 1 will be talk about the rules of Wordle. Do you see it? Is it big enough? Yeah, it should be. Step 2 is to complain a little bit about the 3 blue 1 brown video. Step 3, that was step 2. What's step 3? What is optimal? So let's talk about what should be our goal. We should define optimal, and then I will grab some dictionary from the internet and we'll start coding. First, Wordle, you can grab a link, for example, in the description, is this game where you type 5-character words, and from this you will get feedback. It would be nice to get different kind of feedbacks, and not this. I want to see something with yellow as well. Yeah, always green means you got the character exactly, it's on the proper position. Black means this character doesn't exist at all, and yellow means this character exists but not in this position. I'm going to implement a program that plays this game as good as possible. We will later decide what it means to play as good as possible. Okay, so I showed you Wordle. Second step is 3 blue 1 brown. This video, I was very surprised seeing something like this from 3 blue 1 brown, where it's just a heuristic. We solve it in a nice way, but it's not optimal. So I don't know. I think the title used to be different, like solving optimally. So that wasn't optimal. Here it's just about heuristics based on frequency of characters, frequency of words, and then considering various possible first 2 moves, and depending on that, seeing what is left. But instead, let's try to make it optimal. Right, and then let's start. Let's talk about what is optimal. We can define optimal as minimizing something or maximizing something. And here, what I'm going to optimize is the average number of guesses. So my goal is minimize the expected value of the number of guesses. The video by 3 blue 1 brown wasn't optimal. I'm not building UI, I will just display some stuff in my browser. Okay, then what's next? Step 4 is grab dictionary, and now we are doing this. Step 5 will be implement some logic to match 2 characters to say what is the feedback. So why is it so low? Here we go. Then create a function to compare 2 words, because always when I get some feedback, well, even to simulate it, I need to know the feedback. So this is the current step. So let's do that. Wordle dictionary. I think it's possible to get it somewhere here. How do I get inspect? Somewhere in the source code there is all the words should appear. Can I Control F it? Control F, laser. Not found. Yeah, it must be somewhere here. But I also saw it online. Wordle dictionary. Yes, we are today solving, we are doing Wordle solver. Anybody has a link to the dictionary so I wouldn't need to go through the source code? I saw it earlier today or yesterday. Inspect sources. Okay, let's grab it from there. Inspect sources main. Okay, it is here indeed. Let's copy this whole thing for now just to Genie. What do we have here? There will be just a lot of words. How do I quickly find where the words will start? Okay, they are here. They start from cigar. Sorry about the font. I will fix it in a moment. This is the dictionary. Where does it end? But I also saw it in the text version. Just somebody provided. Thank you, Paluszek. Yeah, that will be more convenient. How many characters do we have here? 12,000 by 5, so that's around 2,000 words. But this link might be just more convenient. I also saw a word, well, this is 12,000. That's, I think, more than there should be. Well, here we have just 12,000 characters. Are we getting there? This is not the best way to do it. Nope. Okay, then instead let me use this. Oh, now in C++ I need double quotes. Issues. The dictionary Free Blue One Brown used was around 90,000 words. I thought that there are 10,000 words that are accepted by and 2,000 that actually appear as words. Complain about Free Blue One Brown because it isn't optimal, and the title first was solving it optimally. Okay, the dictionary is here. I will change all the quotes to double quotes. And now we can use that. My program at first will not be fast enough, but that's fine. I will just remove some of the words. I need to later put this in a file. Genie is so basic, use Vim or this. Okay, if you say so. But did you try Genie? No. I think that I will later turn on the browser when I talk with the chat more, but now it's time to work. So, function to compare two words. I need a function that returns what is the comparison between two words. that, now what is a comparison? It's a sequence of, let's create a struct for that, like feedback or info, where it's an array of size 5. Then there is a function that matches two strings, 1 and 2, and it will return info, an array of size 5. Where, what do we have here? Info of I is, there is black, yellow, and green. I will also maybe display it with colors in terminal. But for now, let's say that I can also match just two characters. Oh, you don't see it. No, not like that. It's not enough to compare two characters. Also, there is something tricky. If two characters are there, then the first one should be matched yellow and the other one should be matched black. And those two strings are not symmetrical. I need to say that there is a hidden string, and I need to say that there is a guess, and depending on that there will be feedback. So first of all, for every position, if guess of I is equal hidden of I, then this is exact, let's say. Could be enum, whatever. Exact, then there is yellow, I will say, and none. Don't expect a very nice code. It is supposed to be fast and efficient, not really the best possible implementation. Then if this, then exact, else we are looking for any other position that isn't yet matched exactly. Before that, or could be later? Could be later. Maybe first let's finish this iteration, then by default everything should be none. Now go again. If something is not matched, if not used of j and it matches exactly, right. If not used and guess of I is exactly jf character, and break, I think. That should work. Let's verify it. Match of hidden word, let's say, is, what can be the hidden word? Let's say coder. And I'm guessing, I don't know, bolder, bold. But I want some matches. It will be, oh, there was already some match, boldy. First, let's print it in a stupid way. This should just give us a sequence of 1s and 5s. It compiles for a lot of time. I need to move dictionary to a file so it wouldn't every time recompile. Yes, I'm moving this to a file. This is annoying. Also, today, for the first time, it might matter how much memory I have. In this virtual machine, there is 23 gigabytes. I can rerun the machine to give it like 28 gigabytes, and it might be needed. Same for the number of cars. Yeah, I don't know why it takes so much time. So let's move this to this file. I think I can just leave it like that and parse it properly. So in in.txt there will be this style of files. I can now remove this. What's the way to scroll to the top? I will cheat a little bit. Let's read from in.txt, or well, it could be from any file. Let's say that it's from this one. Let's make sure that the length of everything in this file is what, 5 plus 3, 8 characters, and then I will need a substring from the second position. This is dictionary. I always forget the function for substring. Do I give positions here? Let's run reading. Why is it still compiling for such a long time? Is something wrong with my CPU? No, I will reopen Genie. Now it's fine. One too many. So apparently this is length, not the last position. Yeah, sorry, I'm not looking at chat every 1 minute because I want to work. Different from the original one, it only matches each character of hidden word at most once. Well, I match at most once. Do you mean that they match many, many times? Oh, I see. So I shouldn't use used. What happens if... Can we test this? Can I now ask about something with multiple Ds or multiple E? No, give me a word with multiple E's or multiple D's. Deader. Peace. Bees. Every. Every. Okay, I didn't expect that because apparently there is character here, so it didn't answer my question. Deers. Okay, deers is, no. I want something with 2 D's. Add there. Is that a word? Okay, this is not yellow, so it should match with everything. You're saying elder is the hidden word? Maybe. We'll never know. Just to annoy you, maybe I will leave this. elder. Maybe. Who knows? Who knows? No. Okay. So we're not using, this D was not yellow, but I guess the theory is that we, Maxim said that we can use a character more than once. All right, then let's change this. So I don't need used, or at least I don't need to use mark used here. All right, now 2022. I want to print in a nice way, so let's make a function that prints C++ printing colors in terminal. This is a way to start using red. And now let's print a character, then a new line. Nothing was printed, or at least I don't see it. Why is that? Maybe because I'm mixing cout with print. Why was nothing printed? Unless it is printed, but it is maybe in color? No. What did I mess up? If you only print yours, let's verify the chat theory. Elder. Okay, so every E is colored yellow. Okay. Is something wrong here? Print guess. Yeah, I don't understand. Are you using some tree structure? Not for now. Wait, I see bold now. What's going on? Unless this completely messed things up. Yes, so now I don't see anything. Maybe I've misread this. There should be M at the end. Okay, good. So now if a of I is equal what exact, we want green. What is green? 32. Just like red was 31. If this is yellow, then let's choose yellow. Yellow is 33. Else, if it's none, let's go back to white. What is white? 37. And at the end, let's get back to white. So bold in coder, it found one green, but I also want one yellow. It didn't work. And because there is something wrong with match, I believe. You're missing the last string to close? Never mind. Okay. Also, why am I displaying Notepad for the whole time? Regarding the questions about free blue and brown, sorry, because I see this question a lot. I just said that the video was first titled Solving Wordle Optimally, and that wasn't really optimal. That was my issue. Now, coder versus bold. Something is wrong here. I'm not finding yellow. If guess is none, iterate all the strings. If I am equal to j character there, and that one is not used exactly, then change to yellow. Looks good to me. Debugging. But for me, all the characters are of the same time, even though B does not exist, but DE do exist. So what did I do? Not guess is none, A is none. No, now it works. For coder, we can verify it here. Hidden is elder. Let's, in a loop, read a string and say match of hidden string and my guess dot print of guess. Now we can check. What? Why? Oh, because I'm reading from free open. How do I close? Still bad? Because now I wanted to read from the input. Can you try readers as a guess string? Yeah, I will try various strings. In a moment we will be able to check with many strings. Let's verify that the issue is here. Yes, the issue is here. I cannot read. Mount order, I guess I just missed an email or something like that. If you write to me again, to my, for example, email, we can talk. Will the loop stop? No, it isn't supposed to stop. I want to forever read a string and just print the colors. But for some reason I cannot do this. Let's try it for now in a different way. For every string in coder, maths, force, every, elder, and somebody suggested rears. Does it match the drawing? Other, every, yes, it works. Good. I'm still not sure about the reading part. While sin, yeah, that should read until the end of the file. And then when we get here, I hoped that this would close the file and I would again start reading from standard input. Rears gives 2 yellow. Oh yeah, so first I used it so that I first implemented it in such a way that rears would give just 1 yellow, but this is not how Wordle works apparently, somebody told me in the chat. There should be 2 yellow. I first thought that only 1 yellow should appear for rears. Try if stream. Yeah, I will try something else. Okay, now we can ask questions, but I see that the initial white is different from this white. That's a small issue, that it is changing my font, but that's okay. In Wordle it's one yellow indeed. Right? If it's one yellow, let's move it back. Now yours will be one yellow. Here we go. Against the hidden word elder, which is the today's hidden word. Okay, then thanks. Now that we have this, let's try to ask some question and then remove from dictionary everything that is not consistent with me, which will be our first basic strategy, and we'll see how it does. We'll call this maybe random strategy. And given a hidden word, yes, given a hidden word, I will try to here compute how good it is on average case. Maybe even we will return a double, saying on average, how many guesses do we need? But for a hidden word, it will be just deterministic. Well, unless I randomize. Never mind. There is remaining dictionary. While there are at least 2 words there, so I'm not done yet, I will choose a random word. Choose a random word and then compare it with hidden, so get some feedback, and I know what feedback that is. Hidden comma s, and for every string from dictionary, let's try if we get the same feedback, and those will be new remaining strings. So for every candidate in the dictionary so far, if he would give us the same feedback, the new remaining, push back this candidate. At the end, we need size exactly 1. Let's with assert guarantee that. And I can also assert that this one word that remained is equal to hidden. So we would see what our program does after here getting the feedback, which is an array of size 5. I can also print it, which there was function print for that. There is no equal to operator. Let's create one. Not in match, in info. I just compare 2 arrays of size 5. And that's our random strategy. Let's try random strategy for elder. Remaining size wasn't 1. That's suspicious. Maybe the dictionary is empty. Yes, the dictionary is empty, so I didn't use if string properly here because it's in.txt. And now I understand what somebody told me earlier. Yes, I'm reading from input.txt. It seems that I'm guessing without any colors. Is that possible? That's suspicious. Oh, well, it's possible if it's uppercase versus lowercase. This is suspiciously long. Let's also print every time the remaining size. So I have 10 remaining words and I cannot distinguish between them. Is elder among those words? Yes. Even if it isn't, after I get some kind of feedback, I should eliminate at least this one. Something is wrong. After not everything is green, at least this string should be removed. Because this string with itself, it would be all green. Oh, here, if this maybe as a hidden word against this is equal to info. Let's try now. That's better. We needed 3 guesses. Let's try some other word like elect. Three guesses. And now let's repeat 100 times. Choose a hidden word at random. Try hidden word at random and try the random strategy and let's see what it does. Always we start with 13,000. Why can this happen? Oh, because I stop when the dictionary size is 1, but I don't necessarily guess this word. Yeah, again, then here in Flick we got some feedback, and out of the 29 words only 1 is remaining, but still we need to ask. So I should say here while true, and only stop when the feedback is perfect. It is perfect match, let's say. Then break. And I don't even necessarily need to get dictionary of size 1. I might be lucky, that's fine. We need to implement is perfect match. Now the last number, the last string should always be green, but I'm not choosing a random character. I'm always choosing elect. I see. Hidden. Okay. If the hidden word is gray, I need 6 guesses with the random strategy. If the hidden word is Bottes, I need 8 guesses, which is very bad result, obviously. Now let's try an average, or let's try all of them, but it will be slow. No, everything today will be slow. If I compile with optimizations, how long does it take? 100 words took 0.1 second, so 10,000 words will take 10 seconds. That's fine. for every hidden word in dictionary, let's do this, and let this function return the number of guesses needed. Average divided by the dictionary size, that will be the average. Also, we can, for example, get the maximum. Random strategy should give us the number of queries. Whenever I ask, queries plus plus, and let's see. What should be the average? How do you think? I'm guessing 5.5. I think it's reasonable. Well, 4, 4, 5. No, it will be below 5. Or maybe. But I said 5.5. 7? 4.5? Oh, let's see. Lead code today? No, no. I'm busy with this problem. It was supposed to take 10 seconds. I wasn't far away with my 5.5. Was the closest. Fat Fertile was closest at 5. So it's a bad strategy, and very often it will lose. I could print here different statistics, like how often does it lose, but of course it's a very bad strategy. Now, in 3 Blue 1 Brown video, you will see a reasonable strategy being described, something that, for example, sorts by frequencies. But I want to find the best strategy, so in some way we should explore all possible strategies. What is a strategy? A strategy is a mapping from the current state of the game to what kind of move I'm making right now. In chess, if you want to describe your strategy, that would need to define in any possible scenario what will be your move. This mapping from states to moves is called a strategy. And we cannot iterate all possible strategies, not just by, because the number of states is huge in this game, but maybe recursively we can do it in a faster way, so not explicitly try all strategies, because a lot of them are equivalent to each other. In particular, if we first ask about one word and then about the second word, versus you ask about second and first, the feedback is not different, so those states will be the same. Also, for the sake of practicing when reading, I will make my life easier. I will only, let's say, accept the first 10% of words for now. So this is a huge simplification. Dictionary resize, dictionary.size, even by 100. It's now only 1% of real dictionary. Why is this? First of all, when I run something, I want to see the result fast. Second, I don't want to freeze my computer. Of course, right now it very quickly computed, and the average number of guesses is 3.5, because the smaller the dictionary, the easier it is to guess. But we want to now implement something optimal or near optimal, make sure for this smaller test that it works, and only then run it for bigger tests. First 1% alphabetically, yes, I think so. So when testing, we need to choose words like abaca. If I choose 1% randomly, I will not be able to test conveniently, because I will not know which words were chosen. At least now I know that when I'm looking here, the first 100 words are in the dictionary. Expected values, we're not learning expected values, but we are indeed using them. My goal is to find a strategy with the smallest possible minimum expected value of guesses. Now, what will be the good strategy? and let's make the summary of stuff so far. As step 6, we implemented random strategy. Step 7 is decrease dictionary size. So here I removed everything but the first 1% of dictionary just for testing purposes. And step 8, which is what we're doing now, is explore all strategies, which will take a lot of time, and we'll try to make it as fast as possible. I don't want to use heuristics. I don't want to find a good strategy, because that would be just sorting by frequencies or something like that. Frequencies of characters or words. No, I want to find the best one. Minimize maximum number of guesses, because I think it's too easy to do that. For sure, it's possible to win every time if there are at most 6 guesses, or maybe not, but there will be many strategies that achieve the same. So what about this? We optimize the pessimistic case, and then in case of ties, we optimize for the average number. That would be, I think, the best. It's okay that now they are all starting from A. I can try different dictionaries as well. Okay, now let's start implementing. When we're talking about averages, we need to, the average will be a real value, so a double type. And this is basically a DFS. What this DFS would do for first maybe, I wonder, oh, yeah, I remember what that was. I need some drawings. Here's what I'm going to do. Let's imagine tic-tac-toe. Then your first move can be to play here, and then you need to choose the remaining strategy. Your first move can be to play here, and then you need to consider the remaining strategy, and so on. In tic-tac-toe there are 2 players, so depending on what your opponent does, there would be some new state, and from here again you have a choice. There is no second layer here, there is no opponent, but I'm going to run DFS through this tree, because what we get here is a tree of states, where the first node of this tree, the root, is the starting state, so nothing is done. And then from every state there are a lot of moves I could make, and for each of them then I need to again make another move. How can you traverse a tree? With DFS. But with this DFS isn't on some fixed tree that exists and I just go to children. No, I create children myself. However stupid that sounds. It's related to minimax. Okay, DFS for... Now what is state of the game? It's the history so far. One way to represent the history would be to store a sequence of pairs string comma info, something like that. But this history anyway, what it gives us is the remaining dictionary. So I'm just going to pass that, the dictionary. This is the remaining dictionary. Maybe I need to pass the move ID, but I don't think that's needed. Then consider all the possible guesses. And now this is not really correct. I will for now iterate over remaining. It is allowed and it might be optimal to guess something that is no longer possible. If you see that the possible words, remaining words, are wordy words or maths, sure, you can ask about one of them, but also it might turn out that asking for some reason about elder is a better choice, because it will allow you to distinguish between those. I think it will be extremely rare for this to happen, but it's possible. So I will put a note here, allow guesses outside of remaining. It's unlikely, but possible. I didn't say I want to create children, I said I will create children. That's a difference. For every guess, now there might be various info that we get, and each of them we get with some probability. Like if there is 1000 words here in dictionary and 5 of them give us the same info, we can say with probability 5 divided by 1000, we get this feedback. So for every string in the remaining, we match hidden with guess, and we increase the frequency of this info. I need frequency to know how often I might get this feedback to compute the probabilities. There is no expected value without probabilities. But also, if I want to use a map or a hash map, I need to here create in info, I need to create a comparator or a hash. Later I will speed this up, because right now it's not efficient to store an array of size 5. I will put it into just one number. If this is not that, this is just how you would compare two strings lexicographically. Return false, because if they are not different, you shouldn't return true for comparing if one is smaller than the other. No return statement were here. Okay, now for all the pairs in the frequency map, for all the entries, info, comma, the frequency, there is some probability here. I will call this entry. Probability is what? Entry second, the count, divided by the number of all the words in the remaining dictionary. With this probability we go down into this info, and then I will, with DFS, go here. But what are the remaining strings? Oh, I see, then maybe it's better to collect them. Right? Not only info, but I would want a vector of such strings. Yes, that's a very good idea, because then I don't need to iterate them again. So not frequency plus plus, but instead pushback. Now I have groups. For this kind of feedback, where it's yellow, green, green, black, black, I have this word, and that word. For this other feedback, I have those words, and so on. For each of those possibilities, there is some probability, and with this probability I go down in the FS to a new state. My state is the knowledge so far, the possible remaining strings. Const, 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 what, where? If you're saying that here I should use const and ampersand, doesn't matter right now, this function is heavier. Iterating like this is not a bottleneck. Okay, so here it's vector of strings. But sure, I can use a const here, but again, not a bottleneck, so it doesn't matter. Entry.second.size. And we should go with DFS into entry.second. And that's it. Now, DFS should return something. It should return the best possibility. I minimize the number of guesses. By default, the number of guesses needed is, let's say, infinity. And here I will minimize it with something. I consider this guess. Let's compute the expected number of guesses in this case. and then we will minimize with this expected number. Here I have if v plus equal, with this probability I have that many moves, plus 1 because I'm making a move now. If DFS tells me for this remaining state on average you will do 5 operations, then I'm saying, well, including this first step, I have 6 operations with this probability. This should never be empty, and it's an oversimplification, but let's say that if remaining size is 1, then return 0. That's not really true. So to do, not really true, because I really need to make a guess. Okay, am I done? I think so. And it runs. Let's add time. And instead of waiting forever, let's just try with fewer words. Oh, it ran in 2.5 seconds. And on average, I needed 2.2 guesses. Let's see how the time increases if I allow for 2 times more strings. It was 2.5 seconds. Everybody keeps asking about free blue and brown video. That it's not optimal. I'm trying to make a better program. And how much the time here increases will allow us to estimate how screwed we are. Now we explored all strategies. Step 9 is optimization. So I will try to make this faster. Are we done? Not yet. Am I using a lot of resources? Only CPU, the memory is fine. Of course I should make a video about free blue and brown being wrong, if he's wrong. I still claim that his title was first about solving stuff optimally, which is just not true. My CPU, I don't know, some 16-core Intel. Right, so we see here that the time grows a lot if we use bigger dictionary. So this code will not finish even in a year if I allow for the full dictionary. Yeah, so it was 2 seconds versus 100, so 40 times slower or so. The average number of guesses increased because now it's now what? There are just more words. The bigger the dictionary, the harder it is to find the hidden word. Oh yeah, exactly. Original title was The Mathematically Optimal Wordle Strategy. And then he showed a bunch of heuristics. So, come on. Which time is considered? Whatever. 1 minute and 33 seconds. I don't remember what was the difference. What, I'm doing something wrong? Pushes back hidden instead of guess. Yes, I here iterate over all my possible guesses. And for each of them I compute stuff. Yes, let's just look at this value and say that my program is very fast. Now, let's get back to smaller dictionary size, 1%, and let's do some optimization. It should be still 2.5 seconds. 2.5 seconds. Now, oh, also this is not true. What should I do about it? I guess if If info is perfect match, then I can continue, because then I don't want to go further. Otherwise, I should continue. Infinite loop? No. And I got down. Why did I go down? I know, because sometimes I get lucky very quickly. So on average 2 guesses for this dictionary of size 100. Without classes, too powerful, sure. Yes, so using heuristics is not mathematically optimal. It's just heuristics. It's like solving an equation and finding a solution versus all solutions, let's say. Hyperfine program, I don't know what it is. But now, I want to here add some memoization. First, for that, for cases where I know what I want to print. I want to print for statistics the size of remaining. Almost always it's 1 or 2. Then here's some speed up. If remaining size is at most 2, then I know the answer. If it's 1, then I need just one guess. If it's 2, 1.5, right? Because I will guess one of them. With 50% I'm right, with 50% I need one more guess. Let's try the time now. It's faster, but it increased. Why did it increase? Because I'm computing something wrong here. If I make this perfect match, I still should add 1. So this was not right. Or is it? I think EV should always start as 1 divided by remaining.size, because with this probability we get it exactly right in one operation. Let's see. Now will the answer change? No, it didn't change. That's a good sign. It means this is okay. Wordle is open source. I don't even know. I don't know where I got this dictionary from. Somebody gave me a link, but it's a dictionary of 10,000 words, 13,000, and for now I'm using first 1% of them and optimizing the code. Now, if this is not 1 or 2, what are the sizes? Is it often a big size or not? Very often we have only 3 words, 4, 5. Maybe there should be some logic for them, but also I'm interested in knowing how many calls we have in total, just to estimate if this will fit in memory. Can I do memoization? One million calls. Well, right now it will fit in memory, later it will not. Depending on the final situation, the answer is the same. So now I want to say map from dictionary to the answer. I will call it cache. And when returning, cache of remaining is this. Faster or slower? much faster, and the answer is the same. From 1 million states we got down to 13,000, but I'm also interested in how much memory I'm eating. 8 megabytes. So for now it's okay. Let's now do 2% of the dictionary. And again, the dictionary is much smaller, but I'm solving this problem optimally, with one exception, that I'm only asking about strings that are still possible, a possible answer, while it might be optimal in some rare cases to ask about another string. With 2% of the dictionary, it took much more time, but also it took now 100 megabytes. So I cannot do much, I cannot go much higher. I can try, let's say, 2.5% of the dictionary, and I think this should already be like 1 gigabyte. I'm using 2 gigabytes in total of my RAM, which is fine. I'm of course scared about freezing my computer. Do we have some limits? No, that's not good. Quarter of a gigabyte right now, with 2.5% of the dictionary. I should add this information at the top. Using 2.50. I want to round this. Let's say round. Does that work? I want to divide by float again. 2.5. Yes, now it's nicer format. Well, I should have just rounded when printing. I'm stupid. Never mind. What is minus f in command time? The command time will give you various statistics, and I just want the memory used. I will show you what command time prints in Linux. It prints, you know, a lot of stuff like CPU used, memory stuff. And with minus f I can format it, and I only want the memory, and this actually is not part of the command. This is just print. So this KB is, you know, I could here say this. It still works. It just prints it. Not all of the strategies could be explored on a normal computer. We'll see that. This is why I have a live stream. I want to try it. Now it's this is the thing about algorithms, is that they can speed things up. Let's say knapsack. Knapsack on 50 elements should take, I don't know, months to compute at least. But if you use a polynomial algorithm, instead it will take a second, depending on data size. But algorithms are here to speed things up. And a lot of competitive programming problems are about solving something optimally. And you cannot do it with brute force, you're right, but still maybe you can find the optimal strategy. For example, by adding memoization. This is really a DP problem, dynamic programming, and maybe even I will switch from recursive to iterative implementation eventually to make it more efficient. Next thing is that just like in chess, maybe the endgame should be played differently. So if there are fewer than 10 words, then something. And also the beginning, maybe, the first move in some way should be considered in a different way. In particular, I can iterate over the first move and maybe clear the map between the first moves. Let's see how it affects the memory and time. Can I do this? No, I don't want to read. Yes, VOD will be on YouTube. This is, by the way, worse than I expected. I thought that for 10% of dictionary I could run it immediately, but that's not true. Now I want to see the effect of clearing the cache between every first word used. Let's go with 2%. 2% takes how much time? This much time versus also let's print the memory. And now for every first guess, after making this guess, assuming that this is the first layer, clear the cache, because I'm not sure if the first guess should be treated independently so that we would lose some time, but we would improve the memory and we could actually run it maybe for multiple days for the whole dictionary. So let's do this, and when going here, ID +1. This was 100 megabytes and 10 seconds. Okay, but now it will be very slow, I think. So let's try also for 1% of the dictionary. Oh, it's not slower. At least not significantly slower, so we should be fine. Let's wait for this to finish. Later I need to figure out a way to print memory and time at the same time. Wait, no, 2%. So now time increased from 10 seconds to 21 seconds, which isn't a big difference, only twice slower. The answer is the same, which is a good sign. But the memory I expect to decrease from 100 megabytes to much lower value. 17 megabytes. Nice. Where is chat? I'm not displaying chat on the screen because I'm not reading it much anyways. What now? I can improve this a little bit. In cache, I shouldn't store the whole vector of strings, just a bit set or something like that. But I need bigger improvements. I need bigger improvements for sure. Chat lives not matter. Sorry. No, Genie is not different from other editors. The only thing important for me is that if I make a mistake, it highlights where the mistake is. If you use Vim, and in order to compile you need to look at the other screen and see that the issue is in line 67 and actually find that line, sure, with a command, then how is that better than seeing the line immediately? Highlight it. If your editor does that, your editor is fine. solution summary, because I'm sure many new people joined. What I'm doing right now in Wordle is I'm considering all possible first moves and then all possible second moves and so on. And depending on first moves, like what is a word starting with A? Let's say that this is a word. It's not a word, but let's say so. Then this is a new state. I find here what are possible, what is a set of possible words, and I choose one of them to be the second move, and so on. I continue like that. It's an exponential solution. It's very, very slow. Yes, same thing here. So I explore all possible strategies, basically, all possible moves, all possible first moves, second moves, and so on. It's not enough to just say that my sequence of moves is first I ask about this string 1, then string 2, then and so on. It's not a tuple of size 6. That would be easy. Instead, it's this tree, the decision tree, where at every new state I decide, well, I got this feedback apparently, so now what I need to do. So it's not, here it was simplified drawing. What happens is that I decide that I go with Abaca, but then, let's say, an opponent tells me, we can think about it as a two-player game, what is the feedback, and depending on that, I have different kinds of sets of words. Abaca is an accepted word. Nice. I don't know what it means though. So subsets are not enough here because first of all we don't know the hidden word, so it's not that there's hidden word and a subset of it. Second is that sometimes we know that a word is somewhere, right, but not necessarily in this position. Considering the guess of each character separately, maybe. But this is very convenient. And I'm not interested in improving the memory tenfold. I need a much bigger improvement. Though, the memory isn't that bad because it's limited by polynomial, but like d to 6th power, and it will be in practice much lower than that. Even if we start with dictionary of size 10,000, after 2 guesses we are left with big dictionary. Now I wonder if we can get improvements like in A-star algorithm, where it's best first search. So with some time heuristic we can eliminate some possibilities. The same happens in min-max with alpha-beta pruning. So there was some coding, now I need to think. King of Delphi, I agree that there are various ways how I can encode the current state, the current information. In particular, it's useful because it allows us to estimate the number of possible states, but I need something bigger than that. I don't think it slows me down a lot that here I have this vector of strings. Don't get me wrong, small improvements like ×2 are important, and this is what I achieved here by making an if for 1 or 2 words. But I anyway need something big. Which is the best average tree depth? Something like that, that's right. I compute some kind of expected value here with probabilities, but you can assume that it computes average depth. Let me think. And I'm thinking about pruning, about choosing the order of strings, But pruning boils down to deciding that we shouldn't follow this path. So if we have some candidate for the answer, like we know, let's say I first consider using a common word like crane with a lot of common characters, and I got some answer here. Maybe on average I here get 3.9. When considering something else, whatever that can be, like abaca, maybe I can quickly decide that, hey, the average here for sure will be greater than 3.9. Yes, I can do that, because I built average one by one, okay, and this might be the big thing. Okay, here's the idea. I sort words by frequency, just like 3 blue 1 brown did, but not for correctness, for speed. I will anyway consider all of them. And when I consider something nice like crane, and I get the answer out of it, 3.9, then what happens when I consider a different word, like abaca? I get some kind of feedback from it, and for each possible feedback, I get what is the best strategy in this case, and if it turns out that I get green, black, 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 then here on average the remaining number of guesses will be 3.5, which is fine. But I here consider one subtree, second subtree, third, and so on, and there will be a sum of them, some of those probabilities already are average, and if once this exceeds 3.9, I can stop traversing further. I will not care what else might happen. Why 3 blue 1 brown is the biggest topic in the chat today. His algo is not trash, it's just not optimal. Okay, let's try to code it. Now I will do a pruning where I know the best answer so far. Let's get down to 1% of the dictionary for testing purposes, and I will not clear the cache. The answer should be 2.99. Also, all the changes I'm making, they should not modify the answer. Here we see a different score, but it's because I changed the dictionary. Also, I don't want a counter. So using 1% of dictionary, I'm getting this average score. No. First, if EV is already greater than best, break. Didn't help much. Actually, there is just some fluctuation. But it will help much if I sort things by frequency. By frequency of characters, I believe. Is it reasonable to always do that? I hope so. So before we run DFS and after reading, let's sort the dictionary using some function. Can I do this? I can, good. Return frequency, or get frequency of A is greater than get frequency of B, where get frequency will be the sum of frequencies of characters. Char frequency of X. The way I'm typing this is far from optimal in terms of speed, but this is not bottleneck. You shouldn't optimize parts that aren't a bottleneck because it doesn't affect the final running time anyway. So this thing I'm just implementing in a convenient way, not to make a mistake. That's it. Baka is the first word. It doesn't look sorted. Is it sorted? Or maybe Abaka is indeed the most common. It's not sorted lexicographically. I guess Z is uncommon. Stuff with A and E should be early on. With X, it should be late. Maybe it is sorted by frequency, but still the time didn't improve, and that's bad. Maybe the dictionary size must be bigger for this to happen. How many words are there in dictionary? 10,000 or so. It contains 3 as. Yes, it makes sense. But if this happens, can we see an info about it? So I got some improvements. I wanted to make sure that this at least sometimes happens. I think we need a bigger dictionary size to see any difference. I think this used to be 10 seconds. And it is still around 10 seconds. This value was just like before, 3.2. I think that was indeed true for 2% dictionary. How would you know if you've got the correct solution? First, some sign is that nobody online provided a better one, and there are some answers online. Here I found a solution, the strategy that on average gets 4.1 guesses. Second, it's about not making a logical mistake. How do you know if you solve a math problem? If you know math enough, you can prove it. So here, coding and exploring all possibilities in some order, all possible strategies, should give us an optimal strategy, unless I make a mistake. Yes, it's about not making a bug. I thought that this will be better. Maybe I should sort the feedback as well. Hard to say. I can also pass down the needed value, and if EV exceeds it, I can already break. But what is this needed? I think it's best minus EV so far. No, but it happens with this probability. Yeah, because of probability, this is stupid. I shouldn't do that. Maybe I should show some statistics about how often this happens. Top of optimization. If you consider all strategies and you choose the best of them, that's optimal. What do you mean other technology? There is a finite number of strategies in this game, no matter what computer you use. Even with pen and paper and thousands of years, you could invent the best strategy. Same happens for tic-tac-toe, same happens for chess. Some games are too complicated to solve them optimally. Checkers are solved optimally. Chess, I don't know. I don't think so. I know we can also do this. No, I cannot iterate like that. If EV plus the remaining part, which is frequency.size minus already times 1, because that's no remaining count. If I have 10 options to consider, I went for the first 5, then already I can estimate that the last 5, they give me at least one possibility each. I can estimate it without running. Now I want to say, if I already see that the score so far, the sum of scores so far, plus 5, if that's too much, I don't need to continue. And this is an example of pruning that is supposed to speed my program up by eliminating states that I see clearly they are not optimal. Not because I just think so. I know it. Because of inequality. If perfect match, then continue. This is fine. So already was 1. Here already minus equal count. Reminding that size minus already times 1 divided by reminding that size, I believe. Let's verify, and the easiest verification is the answer should not change. 3.20. I don't think that's correct. Let's make sure that if I ignore this, then everything is fine. Yes. What did I mess up? The remaining size minus what I already processed divided by this. For each of them I add at least 1. I don't see a mistake. Double. No, it's casted to double. Already plus equal count. Oh, right, of course. Of course. It didn't help. Already plus equal count. That's fine. Passing variables by reference. Sure, I will do such optimizations at the end, but they are negligible compared to big things like what I'm doing now, I hope. It's suspicious that so early we break. If I do this, everything should be equal. And it is equal. If the EV so far plus what remains in this map divided by everything, so this is basically the probability that we still do something, And for each of them we make at least one move. In my opinion, this should be correct, but it's clearly not. Let's print guess. Best and EV. Oh, I see. In this case, we should actually do this. EV plus equal inf. Otherwise, I'm breaking, but I still think that this is a valid answer. Okay. But there is an easier way to handle all of that. Just don't count ones here and instead do it there. For sure in EV we have this one move because I'm making it, and then this remains, then I don't need anything like that. The answer didn't change, and sadly the speed didn't change either. Is this harder than any CodeGen problem? It's different. It's very different. It's more like Google hashcode problem. Vector is sorted anyway. I don't change the order in vector, so changing it from vector to set doesn't matter, Gupta. I never change the order, I think. Let's see, so almost always we stop, but anyway we explored most of the possibilities. And that's very bad. Maybe I should find a better estimation before running. Like if I see that in some case there are two words, I can estimate it as 1.5. Again, this estimation is just for the time speedup. Almost always the speedup is useless because here I considered 8 out of 10 entries, so I did most of the work. Sort the frequency map. You mean this thing? That's reasonable. So I can iterate it here, but first I would sort by the number of strings. So I would consider likely things first. Well, let's saved. Let's have a variable for how much I save, how many operations I save. My goal is to increase this number, obviously. And I think we need to get back to make this faster. 70,000 saves are saved. Now I'm iterating the possibilities of feedback, starting from those that are very likely. So those that are a result of many strings. Vector, of course, vector is not defined. Vector. It was 70,000. Now it's 400, so that's better. The score didn't change, but the time didn't change either. At least not significantly. Can we make this game on Polygon in form of interactive problem? The only possible issue would be copyright loss. But sure, you can make it an interactive problem. I'm sure even you can upload it again, but there might be some copyright issues. You can upload it to Codeforces Gym for everybody to try various strategies, but almost everybody will just, sort by frequency. How much execution time do you want? 1 day, at most 1 day. And right now, as I said, I think we're not looking at less than 1 year. Priority queue. No, if something doesn't change, you should sort it, not use priority queue. Don't replace sorting with priority queue unless it's really needed, or new elements are added. How many elements are there in total? So this is not really saved, but sorted frequency, that's size. 400,000 out of what? Yeah, then it was a nice score. I got rid of 20% of states. That's a lot. Maybe big states are still considered, this is why the time didn't change, but getting rid of 1/5 of recursion calls is a lot. So I can now try a better estimation, I guess. If something has at least 2 words, then 1.5 should be counted, not just 1. But it will be tricky to do. Let's try though. The answer shouldn't change, so let's remember the answer, 3.09302. Whenever I make a mistake, the answer will change, which is bad because I'm not here using any heuristics for correctness. I'm finding still the best possibility. Let's change this from 1 to 1.5. So p second size times half divided by remaining size. Now it's just better estimation, because if I know that somewhere there are at least 2 words, I know that the score is at least 1.5 or more if there are more words. But here I need to say not if count is at least 2. And then subtract it back. The only purpose is for the suffix to be computed, to be estimated in a better way. The answer is the same, and the number of saved states increased just slightly from 400,000 to 430,000. Not a big improvement. Can a neural network solve this problem? It can find for sure a good strategy, but not necessarily an optimal one. This is a type of problem where handwritten algorithms are better than machine learning. Machine learning can find a very good strategy, but it will be a local maximum, and it's, let's say, impossible to prove that there isn't anything better. And my goal is to find the optimal strategy. Nonlinear programming sometimes finds optimal solutions, and it can be proved, but it's not viable here. Algorithms for Google's supercomputer. What would that algorithm be? Because this last change didn't help a lot, I will just Control Z it. I don't want to make my code very complicated, which, you know, is dangerous if that doesn't help much. Is that a valid version? Yes, 400,000 are saved. What other type of pruning I can use? Also, should we run it now for bigger dictionary, just in the background? I think it doesn't hurt. Why am I printing something? I print the dictionary. I don't want that. No. I want this. With time as well. How do you print time? U? Yes, U seems reasonable. Saved. I don't really care about saved right now. 1.3 seconds. Now this will be 2% of dictionary, and I also will run it for, let's say, 3% of dictionary. That was 100 megabytes. Let's make sure that I'm not freezing my computer. No, it's fine, 2 gigabytes. We'll let this run, then maybe we'll try 5% of dictionary. If I had a lot of memory, like, you know, terabytes of memory, maybe this already is good enough to run for 1 month, and it would produce an optimal strategy. Also, now I'm not even printing what is the optimal strategy, so let's add that. This will be nice. Best guess. If this is better than best, best guess is guess. But also, just for fun, we can, for every string, just then without this optimization, for every string we can say guess and what is the EV in this case. Half a gigabyte and 75 seconds. That was time needed to solve the problem optimally for 3% of dictionary, which is around 300 words. But you can see, from jumping from 2% to 3% of dictionary, it increased the time from 10 seconds to 70 seconds. So 5% will already be maybe an hour. But now let's use 2% of dictionary and let's print stuff. Here we see that if I start with Agios, it's 2.7. It's interesting why so many of them will give me 2, exactly 2. Oh, because the dictionary is so small that in many cases, then the answer is unique. No. Why is it exactly 2? It shouldn't be exactly 2 because I'm guessing this one. That's strange, in my opinion. Too often I see numbers that are round. Maybe this being rounded. Or maybe... No, I don't understand. Okay, I'll let it run for all of them. Am I not printing only if ID is 0? Maybe you're right. Where is printing guess? Yeah, thank you. We can also analyze that sometimes the program is slower, sometimes it's faster. That's curious. The best first word is aired, and in this case, on average, I make 3.2 guesses. If I start with a buzz, it's 3.8. Those numbers are close to each other, and this is why my speed up didn't help too much. Abaca was 3.5. Adach and Abase are good. It's not a good idea to sort by frequency of the sum of frequencies, because every next A is less valuable. Maybe before that I should use a set of characters. Doesn't hurt to try. So frequency of characters in set. Now Abaca shouldn't be first. Yes, 8 is first. And same for counting the frequencies. I don't care that Abaca is that it has a lot of A's. Well, maybe 2 A's are valuable in some way. Let's leave it like that. Of course, the answer doesn't change. It can only affect the time. Or maybe it's better to care about repetitions. Wordle isn't a crypto faucet for some shitcoin? It isn't yet. I would also like a concise proof that 5 guesses is the best possible worst case. I don't think there will be a concise proof, but once I finish this code, it will be a proof. It's sometimes called proof by construction. If you find a strategy that wins in checkers when playing white, that's a winning strategy for white, and that's a proof. If you run it for a month, and Also, I will be out of memory, so for now that's an issue. It seems to work though. The answers are reasonable, but also they are very close to each other, which is why pruning doesn't work. Maybe pruning will be better if we have a big dictionary. I know what we can try. We can try random parts of dictionary. What was the speed here? And what if we random shuffle? Ten seconds. Much faster. Because now the words are very different from each other, which is promising. I made it harder for my program by giving it a lot of words starting with A, because they are very similar and we don't have that. We don't have many discards after the first guess. That's a good thing. Then okay, what about? And this was 2% of the dictionary. Let's try 3%. And let's try it here because we will see time and memory. It's getting slower, visibly slower, right? Yes. Why was it so slow at the end? Was it because of a big memory, a big map? I'm not sure. Maybe just because those words are very ugly. That was 10 seconds and 100 megabytes. Let's try one more thing. For 3% of the dictionary, I want to here move back, speed up. When we see expected value greater than 100, it means that it was estimated. Oh, that's wrong. Maybe it's not wrong. Maybe almost all the cases are easily discarded. Can this happen? Yes, because we have... Let's quickly pause it. That's very interesting. When, except for the first few options, when we consider anything else, and we consider all those possible feedbacks, and there are like hundreds of them, after summing up first, let's say even 90% of them, we will already get expected value bigger than the best answer so far, and we don't need to continue. So estimating this in a better way would be great. Best guess is fourth word. Later I can modify things. For example, I can allow only 5 guesses. For now, I don't care about the number of guesses in pessimistic case, I only care about the average case. I got lucky with shuffle. Not lucky, just the property of this dictionary is very different. It doesn't have a lot of words that are similar to each other. Now, why is it visibly slower at the end? Is it because of a big map, or because of very few discards? Understanding this might be very useful. Let's also try 5% of dictionary. But that was 100 megabytes. Again, let's finish quickly. Only one word got to the end. 2 words. Then it's obvious from this that it doesn't make sense to check all those different words. But still, my aim is to find an optimal strategy and to be certain that this is the best strategy. But I will now use a heuristic. I will, in the first iteration, only try the top, let's say 1%, because I clearly see that everything else is discarded with the +100 value. And later I will get back to improving the speed. Now only 10% of words are considered to be the first guess, but starting from the second guess, everything is considered. And I got this score. I will now try, memory is fine? Yes, 38 megabytes. 10% of dictionary, so 1000 words. Oh, it's getting way slower. Why is it so slow? I guess at every layer we have more words, but it's a big change. This was, I think, before I changed anything. So what was it? Like 5%, but no, I don't remember what was here. I should, when running a program, I should here put a constant. So when going up with arrow up, I would know what I was trying to run. This was the hacky version. In less than a minute and in half a gigabyte, I did 10% of dictionary, but also assuming that the very first move is among the top 10%. If I change this to top, let's say 1%, which now it will not be correct anymore, can I actually use the full dictionary? So this is an example of how it can be wrong. I considered only first 1% for the first move, and I got the score of 3.306 instead of 3.303. But well, it's some estimation. The memory is fine. What about 20% of dictionary? I'm now experimenting to, understand the problem better. If I use really a lot of words, now the size of this dictionary is not that far away from the size of whole dictionary. It's the same magnitude, being thousands. And now, in particular, I see that for many words in a row, my heuristic didn't help in the speed heuristic in eliminating this example earlier, because every next string here is even better. Tiers turned out to be better than arios. We can use more heuristics for that, like I don't know, carrying about frequency of this character on this particular position. Maybe that will be 2 times faster. Will I do a 24-hour stream? No, I will not. Okay, I need ideas. I thought that this pruning will be a good thing. How else can you prove that some strategy is not optimal? If we deal with the whole dictionary, then using some words must be, for some reason, very bad. How can we show it, though? The only way I see is still the lower bound for the number of remaining guesses. Can I say that if there are 20 remaining words, then the answer is at least 2? I cannot say that. Oh, it's actually slightly better than 1.5. If there are 20 remaining words, and I guess one of them, I have 1 over 20 probability of guessing it right. And even if then I will know exactly what it is among the remaining words, with this probability 19 over 20, it's at least 2. So the score is at least that. Earlier I estimated as 1.5. But this is much better estimation. I will try it now. I removed even my improvement of estimating if there are 2 words or more, the score is at least 1.5. So sometimes we are able to finish earlier. This was 20% of dictionary, but trying only top 1% as the first guess. This gives me hope, because it means that I could clear the memory, I could clear cache, and run this again for the second 1%. I want to see the comparison of speeds. So here, if this, and it's not one of the last 100, now I will try only the last 100, and I think that everything will be slower. Let's put some info here. This was 20% of dictionary, trying top 1% as first guesses. This is just a note for myself. And now this will be trying bottom 1%. Two gigabytes for now. Why am I not seeing anything? Maybe it's just that slow that even for a single word it takes a lot of time. 2.2 gigabytes. It only grows. Interesting. So pruning unlikely cases is a huge deal, because notice how much slower it is if we start with a bad word. If we start with a word with low frequency of characters, something just very unlikely, then we are still left with huge dictionary. While instead, if we start with a very common word, we have smaller groups, and analyzing anything is very, very fast. So it clearly means that I need to focus on pruning those bad cases. Whenever possible, estimating that, hey, this is just impossible to beat the best answer so far. Here's a simple exercise for you. Now compute, when will my computer freeze? But I hope that only if the virtual machine would freeze. You're looking right now at virtual machine with Linux, while the outside world is Windows. So not even a single word was considered? Yes, not even a single word. That's a big difference. Good Coder said, when you choose next node, When you choose next node to visit in DFS, sort your guesses in decreasing frequency of occurring. I already did that. Yeah, I'm considering things ordered by the frequency. Come on, I want to see one word here with its expected value before we run out of memory. But maybe a way to think about it is that we are left with almost the full dictionary. I guess we are now trying a word that maybe eliminates 4 unlikely characters, 5 unlikely characters, and the remaining problem is almost as difficult as the full problem. So pruning is extremely important. Okay, now just like in the drawing, I will use this formula for estimation. For everything in frequency, if p size is at least 2, EV plus equal what did I want to say? That if something is a group of C, at least it has 1 plus C minus 1 over C. The 1 is already here, so I can ignore it. And whenever I get to an element, I need to subtract. I don't need this if. For c equal to 1, it will just do 0. But now I think the pruning is better. What do you want? P second? 4 gigabytes. Oh, it decreased? It increased. Let's get back to top 1%. Then continue, continues fine. This was here. So these are some statistics, and these are statistics now with my new pruning. But the answer shouldn't change, so we should see settle 3.56. Oh, those answers are terrible, right? 1.80, what are those values? I think something went wrong. Arrows 3.72. Arrows, yes, this is not right, so I messed up. How about optimizing 3 blue 1 browns algo? He didn't provide any algo, he provided a heuristic. He didn't explore old strategies. Y might be considered a vowel. Why is this so slow? This one finished in 80 seconds. Oh, maybe it's also around 80 seconds. 5 gigabytes, not even a single word here. If count is 5, I'm adding 4 over 5. Because with this probability, it shouldn't be 4/5 because it should be multiplied by probability that we are here. Let's try this. Arrows was 3.6. Let's see. That's right. That's also right. 61, 57, 57. I would be happy to more often see a value like 100 something, because it would mean that sometimes this new estimation earlier sees that this is not a good choice. Can I estimate even better? If the number of words is at least something, then at least 2 guesses will be needed, but it's hard for me to come up with this condition. Maybe something like this is true. If at least 100 possible words, at least 2 guesses needed on average. But the number of possible feedbacks is 3 to 5th power, which is 200 something. So what we can claim is that if there are more than, let's say, 250 possible words, then yes, the first guess will not distinguish between all possibilities, so in some cases I will need 3 guesses. But that's a very weak estimation. Keep track of used words and then compile the result by using probability of every single word to come up with the word. I'm already doing that. Are we far away? Rounds. Where is rounds? There is no rounds here. Why is this code printing more stuff? One, two, three, four, 5. I will just paste it somewhere. Here's a scary thing. I'm replacing my code just to count something. 26 is 26. It's 26 is 1%. Yes, that's right. But here we have more already, right? Yeah. Why didn't it stop? Acres and escar. Acres and escar. It's here, and then it continues. Did I mess up the if condition? There is no plus plus. It goes through all the candidates. Here you go. I just want to compare the speed. It was 80 seconds and the memory as well. For every word, calculate number of different feedbacks. Yes, you're right, that's much lower. And how will I use it? I can use it. And I still, for the whole time, have this one simplification, one way in which I'm not finding an optimal program, this to do, not this to do, another to do. or warning, was it? The thing is that I only ask about one of possible words, and it might be better to use something from outside that would nicely distinguish between them. You can think about it as starting the game, but you have an ability to use a word that doesn't exist in dictionary. Then maybe you might want to just use AERTS or something like that. And that would be the best start, even though it's not in the dictionary. Do I have warning? Why is this a comment? Warning must look like this to work. Warning is something in C++, but I stopped it from working by moving it to a comment. So it's not faster. It's slower, but it might be because I'm running something in the background. Something that, yay, it analyzed the word gummy. For 20% of dictionary, using one of bad words, gummy, which is in bottom 1% when we talk about frequency of characters, it takes around, I don't know, 10 minutes. Now I'm killing this. Yes, it was more than 10 minutes. And it needed 5 gigabytes. 5 gigabytes and 12 minutes to consider gummy to be the first word, but we only have 1/5 of dictionary. I wonder if it would be better if we told it start with gummy, but we know already that there's this nice word with a score of 3 point something. What is the difference? 3.56. So when analyzing gummy, but we first go to this big group anyway. That's an issue. Okay. Here's why my pruning doesn't help. Because when we try gummy, almost for sure, with biggest probability, we will get feedback, nope, nothing from here is there. And we will be left with almost the whole dictionary. Let's say here dictionary was 10,000, and here the remaining dictionary is 5,000. And because I sort by frequency, I consider this first. I think that first I should get down to those unlikely cases because they are also very small. They will be easy to consider. So go through all of them, compute the expected value coming from those, then go to nope and pass the value saying, hey, I want to beat 3.5. Already from those parts, I got contribution of 1.2 to the expected value. So here I am allowing at most 2.7. And I hope that this will be a better pruning. Sounds good to me. I will be bothered by this warning, so actually I'm commenting this out again. Top 1%, that's fine, but I'm decreasing the dictionary size to, let's say, 5%. Oh, blazing fast. Okay, let it be 10%. And I want to again display the saved amount. And I will close unnecessary tabs. This is 3 seconds. It's reasonable for testing purposes. We can do even slightly more. No, it's too slow. 7 seconds or so. Yeah, 5 seconds. That's good. Saved is 1.6 million. This is the score. I hope that the score will not change. But I'm getting back to my idea of passing the needed value. Well, before that, let me sort in the reverse order. Somewhere here I'm sorting, yes, by frequency, and I want to say sort from least common. Is it slower or faster? Almost the same, but the saved amount was much smaller. That being said, I shouldn't care about this saved like this. I should care about the sum of their sizes. So maybe in both those cases, here in saved, let's print remaining.size minus already. Should be a bigger value than before, not 60,000 but instead 280,000. And if I do this, instead of 1.6 million, let's see, less. I think I ran, no. What's going on? How does Wordle work? I will find it online. Oh, because it was like that before. Now we should see 1.6 million. More saves are desirable? Yes, very much. 1.6 million versus, let's count how many strings we saved, not just how many indices. Not a big difference, 1.9 million, but here's something that I hope will be a big difference. Passing the value, how much we need. I'm saying that if expected value is already greater than need, we can stop and to return. The need that we want to beat in the first place is just infinity. I need to get this or lower. And what's here? It will be best minus expected value divided by p. Didn't help at all because I'm never using need. That makes sense. If the answer changed. So I'm doing something wrong. This is not correct to do. I want to be best. I want to beat best. If expected value is 10 and best is 11, I only can afford one more unit. Divided by p, because here I'm multiplying by p. Looks good to me. It's maybe... Also, it was a mistake to increase the dictionary size. I want this to be faster. So it is 26209 versus 274. Yes, so this if is not right. Why? But I can say this, right? If greater than best. Two 274, that's right. I don't want to get the lower value. The lower one is wrong, I believe. If EV is greater than need, I need to also change it to infinity. 274. Damn it, now it's too big. But it got way faster, so if this is a small mistake, it would be good information. Need is a recursively passed value telling you, hey, if you get down here, if you cross this value, then don't bother counting anymore because you're anyway too high. I need from this subtree to get an average score of 5, and you're already exceeding 5, then don't finish. I also need to here later try both directions. It's not really a warning, it's more like to do. As the first word, we choose a word which has all the most occurring letters. In the next step, either we find a lot of characters of our word, or we eliminate a lot of commonly occurring characters. Anything like that is, just description of a reasonable strategy, but the only thing how I'm allowed to use it, if I want the optimal strategy, is the order of iterating for faster pruning. Is this okay? Two 274, yes, it's okay. So how this is bad? Am I putting a wrong value here? If I'm 5, best is 6, probability is half, then I'm saying you can get at most 2 more, because then this 2 will be multiplied by half. Looks all right. Why am I not debugging the local values? Because my program analyzes millions of cases, so no, if I print anything, it will be printed 1 million times. So what do I do? What time is it? Oh, I'm almost at 3 hours. And to think that I wanted to be done in 90 minutes. I hope you enjoy this return of mine to streaming. I don't understand. Is it because of that? What about cache? Not that either. I can here only increase this value. Wait. Maybe it is because of cache. Will this even be fast enough? Now we see that cache did help a lot. 3.274. 3.274. Yes, so the issue was cache. In some cases, I go down and I stop computing anymore because I see in this particular case I shouldn't continue, but then again I get to the same state and this time I do need it. So the solution is even for 100. Isn't my program completely wrong? Because this doesn't work well with cache. Sometimes I will change my expected value to like 100 and then I will save it. That's not good. Oh, but that doesn't affect best, because here I see something that says best should not be modified. Okay, got it. Here you can stop, but then the best will still be infinity, I believe. So we just should say if best is smaller than infinity, then that. Now I think we can get back to using cache, but cache will be slightly less useful. 3.274. 3.274, yes, 3.274. Can we guarantee 5 moves? Yeah, so analyzing if we can win in 5 moves or less for sure is much easier because of some inequalities here. Maybe it's interesting to find a solution that maximizes probability of winning in 5 moves. By the way, I thought that it's always possible to win in 5 moves. Apparently I was wrong. Okay, we have some number of saved stuff. So now need does work. And I can try both directions, maybe for more candidates. So the dictionary should be smaller, but I need to move this to global constants. But this thing, I want to check top, let's say 3% of candidates. I can even do more. Isn't that surprisingly good? I now consider 10% of candidates. 2 seconds for 5% of dictionary. I would say that it's a nice result. 10% of dictionary, considering 10% of top candidates. Whenever we see infinity, it just means that it wasn't computed until the end. Why do we see so different infinities? No, I see an issue here. I shouldn't then here use infinity. Where is it? Yeah, I should just say it can be infinity divided by the number of words in dictionary, because some smaller subtrees will give you infinity divided by something, and this is not a good value. We'll see if something changes, but hopefully we got 10% of dictionary and 10% of candidates considered to be the first guess in less than a second and less than half a gigabyte. I think that we are saving a lot right now. In a moment, I will compare it with something that doesn't do the need. I'm using a dictionary of 12,000 words. Right now, only 10% of them. If you're only using the solution list, then the worst case is 5 moves. Right? But so the solution list is very short, right? Well, something changed, so it might be different, but the answer didn't change, so at least it wasn't a big deal. Now I want to compare how much even helped. So for a moment, much smaller dictionary, 0.26 seconds, and let's not use need. Come on. It didn't help at all. So all my proning doesn't help. That's very unlucky. It seems, maybe I'm making a mistake, but it seems that everything I did for the last, I don't know, 1 hour, it doesn't help at all. Maybe it will help with bigger dictionaries. .6. .19, that's better, is the answer, right? 3.16, 319, 16, 319. All right, that's a 2 times speed up. And let's see if indeed, now, if that matters. 3.19. Yes, my improvement helped, but only it helps if we sort this from lowest, which makes sense. I said that I want to do low groups first, then go to the big one, hoping that the big one will be stopped. Okay, that's good. 2 times the speed up after so much effort. I can get 5 times the speed up from something else, from maybe squeezing this thing. If remaining size is not very small, let's print it. Remaining size. I wanted to see if there are a lot of big numbers here. So what is here to speed up? Hundreds are very rare. What is the full dictionary size? It's 12,000 divided by that, which is around 1,000. After the first guess, assuming that we start with something common, we have around apparently 100 at most. But it doesn't even happen if we start with this. Arrows allows us to split into groups such that each of them is smaller than 100. But of course, when we go to words groups, that's not anymore true. Now we will see more and more of those groups. Because now we ask about novas, then we will ask about something without those P, E, T, the common characters. Allowed, and now we have 3 non-small groups. And the program gets slower and slower. Can we, for a huge dictionary, consider top 0.1%? Yes, reasonably fast we do that. That is for 2000 words. I also want to see the memory. Now, I'm tempted to just say if which is greater than, let's say, 3. I want to consider 3 words as the first one. Actually, this was also 3. That was 10 seconds. And it was 20% of the dictionary. Let's now try 33% of the dictionary. Okay. My pruning didn't help that much, it seems. Well, if it's now 2 times faster for big tests, maybe it will be 100 times faster, because everything here is exponential, or at least it's a big polynomial. But I think it's time to take a break from pruning and instead just improve the constant factor. I still use here a vector of strings. I can compress it a lot. In particular, I could use here a Boolean array, just referring to which strings are still possible. I can also compress strings. I can pre-process what is feedback for every pair of strings. I can represent feedback as one value, an int, because feedback is always an array of size 5 with numbers 0, 1, 2. So is it time to do this constant time speedup? I mean constant factor speedup. I wonder how often a set of less than 10 words can be completely split with 2 guesses. Good question. And maybe if we get this perfect split, let's stop immediately. So if remaining size is at least 2, and we found such a split that now nothing is grouped, this is it. We can stop. I wonder if this will help. Let's make sure that I'm not breaking my computer. No, the memory is fine. Oh, errors get computed. So in at most 1 hour, and actually much less than that, I can perfectly consider one candidate. At least a very good candidate, because weak candidates are for me much harder to analyze. Got an exam, wish you all the best. Terrific codes, good luck to you during the exam. Does the program take into consideration the probabilities? Only for speed. My program considers all possibilities, but in some order, and this order is decided by probabilities. Multi-threading can help, yes. If I will have a program that I see it will need, let's say, a month, then I will run it in parallel for 1 week. But I don't want to play around with it right now, because I'm going to later modify my code. all single is true if single is false. It takes me around 1 minute to consider one possibility for a dictionary of size 1/3 of the full thing, and also it's 1 gigabyte. But now let's decrease the dictionary. Let's make those a constants at the top. Dictionary percent or something. Let's say this means 20% of dictionary, and candidates ratio. What is the percentage of candidates that I consider? Times the ratio. Remaining size times candidate ratio. I guess 20% of dictionary is a lot. 10%? And too many candidates, I don't care about them really. .13 or so. Okay, now all single. I should just say that this is right. No, not really. Wait. One means that I have the current move. Then when I see a group of size 2, why is it C minus 1? Shouldn't it be C? Shouldn't this just say 2 minus 1 over remaining size? No matter what? And then if I see groups, I add even more. Yes, I believe that for the optimization's sake, this is correct. Optimization improving. When we choose the next node, why the best candidate should be in the middle? I don't see why what you're saying, good coder, is true. If my program runs for 3 seconds, why not multi-thread and get 1 second? Right now, my program runs for 3 seconds for a very small part of the input. I don't want to wait for years every time to run it for some test. So I'm running it for much smaller test, for only small part of dictionary. Right now, it's for 8% of the dictionary. And it doesn't grow linearly. My time complexity is far from linear. It's much worse. If it was linear, then it would mean that running for full dictionary would be 12 times slower, faster, no, slower, yeah, than 8%. And that's not true. Now I want to use this. Right? If I have 10 objects, I will make a guess with some probability that this is just one guess, but other than that, I need to continue. Even more, I have this, because if I see a group of size 5, well, those 4 possibilities need to go even deeper. For now, let's skip this. Here I need to subtract. What do I need to subtract? This is crazy, but I think it's twice count minus 1. Because here I have count and here I have count minus 1. The answer is the same. And it was like way faster. I'm not 100% sure that I got it right. But if so, this is a big breakthrough. And for the full test, it will be hundreds times faster. I think it's okay. Let's try maybe... I don't know what I can try. I can try around different seed to check a different subset of dictionary. But let's do this, just to run it again. This is one run versus, now let's ignore the estimations completely. Is that okay? What did I run a moment ago? This or that. I think I've run 3.22854. Okay, this answer is the same, and now I'm much slower. So it seems that I did a nice improvement. Now I have a real pruning. Okay, let's try bigger dictionary size. 20%. And this time, every next candidate is faster. That might be the very, very important thing. Earlier, the issue was that the worst candidates, they take so much time. It's now 20% of dictionary, and out of them, 5% are considered to be the first move. Take a tea break. I think you're right. Less than 1 minute. I know what we can try now. Again, bigger dictionary size. I want to compute few candidates for a huge dictionary, like just few. Until 5 minutes ago, I thought that today I have no chance of solving this problem, and now I have some hope. Earlier I needed 1 minute per candidate. Now I think it's like 10 seconds per candidate for 1/3 of dictionary. And it's not getting slower. For the first time using half the dictionary. And maybe those are just like 2 or 3 candidates for the first option. So still way too slow, but we're getting somewhere. Now, do I need this? I think it doesn't help a lot. It's a constant factor because we'll get to each possibility. Right, time to make matching faster. Because here I iterate over possibilities of my guess and then iterate over everything hidden, and I have some info. I need to pre-process that. How will I do that? I think that every string will have ID up to 10,000, and every pair of strings it will have pre-computed match. And the number of matches is 3 to 10th power. What's that number? 3 to 5th power, this number. So when reading, let's also run pre-process. Oh, it cannot be here, but because of that, wait. I will make another function. There is info, there is match. Random strategy I don't care about. Pre-process. Now this is something very standard where I feel confident because just normal optimization to make the code faster, not thinking about pruning to make it work, to make something work in 1 month instead of 1 year. Just make it a few times faster. For all pairs, this preprocessing will of course take some time, but then everything else should be faster. Feedback of ij is equal to feedback of ji is equal to match of those two strings. Oh, it's not symmetric, right? Hidden versus guess, we get a different match. So I should actually do this. Ij is match of hidden, let's say that's dict of I, is dict of j. That can be of short type, because 243 fits in short, and that's twice less memory. Feedback. Okay. Now, match needs to return an int. Okay, it does return an int. What do you want? Get the value from int to info. Yes, match now returns an int. It will be harder to display, obviously, but that's fine. And I messed up now a lot of my code. So before I do that, let me copy this. Aeros is computed for half the dictionary. For half the dictionary, Aeros has this score. Now I think that I'm able to leave my program for a night to let it consider just as many candidates as possible, and it will not yet go through all the candidates, but I think that it will be able to find the best ones. Everything late, all the worst candidates will be only worse, but it's not a proof, and I wanted an optimal program, not something that is good, seemingly. No, yeah, I wanted to copy this. I'm very bad at making copies. Wordle CPP, this is Wordle before hashes. Now let's do some refactoring. And I will also remove random strategy, for example. I will not store strings anymore. I will store IDs. So there is a lot to correct here. DFS, I get vector of integers for every guess. There is, well, this can be a string, sure. Why not? For every possible hidden from int, and this later also will be an array of size 243. If info is perfect match, and perfect match is 246 minus 1. Right, because do I remember correctly? No, oh, 0 is a perfect match, even better. This is not from vector of ints. Actually, yes, vector of ints. Shorts could be used, right? Yes, shorts, because I don't want to assume that the number of strings is small enough. Maybe somebody will want to run it for 100,000. So let's leave it like this. Though it would affect memory a lot. Already I will have a big improvement. By the way, here in 5 minutes or so, we computed few candidates for half the dictionary and it took 1 GB. But now it will be like 100 megabytes. It will be much better after I'm done. We should remember the answer though. I can compare with the other file that I saved. Actually, I will open that file. Does it compile? It does. Good. Does this compile? No, it doesn't. This should be feedback of hidden and guess. Frequency. What do you want? I don't want to use search and replace because I prefer to look at every place where I use the string and think about it for even a second. Dictionary. I need to run pre-processing, obviously. Maybe after sorting, like that. And then initially we have everything from 0 to dictionary size. Pre-process. What do I prefer? I think I prefer pre-processing. .05288. Maybe let's run it here on the side. And while this is being run, let's try for smaller input. too fast. Best guess is empty. Where do I assign best guess? Is guess an int? Yes, it is an int. How is this even a legal assignment? Can you say string is equal to int? Why didn't compiler warn me about it? Dict of guess. Best guess is Mares. No, I don't want to print this thing with 100. In a moment we'll compare this versus whatever happens there. What else I can try? I can try changing this to from a map to an array of size 243. I need to get water. It's very unhealthy that for 3 hours I'm just sitting in front of a computer. And some stretching would be nice. Let me put some break. Okay, short break. That's a big improvement from 1 gigabyte and 400 seconds to 1/3 of a gigabyte and 170 seconds. The answer stayed the same, so likely there is no mistake here. And we're getting there. That was for 50% of dictionary, just trying few elements. So already for, I believe that for the full dictionary I can consider a few words and say how good they are. Now I wonder for how big dictionary I can consider all the candidates. Why is this instant? %5 of dictionary. Okay, but now this was 0.35, but if I want all candidates, good. Bad candidates are not slower now. So if I'm not mistaken, oh, sorry. There's still this in the background. I was supposed to have a 3-minute break and I couldn't wait. Sorry. Do you watch the 3 Blue 1 Browns video? It's not optimal. Optimal means the best. He found a good solution. It's like describing a good strategy for chess and saying it's optimal. Why is it optimal? Sure, it's good, but that's it. It's good. Okay, I think I'm very happy about this. For 10% of dictionary, my program works in 20 seconds. And there is still that thing that I'm not trying words outside of my remaining dictionary. But I think it's a reasonable assumption that we only try those, at least for now. So this is 20 seconds for 10% of dictionary. Let's now try 15% of dictionary. No, I am not implementing free blue and brown's solution. I'm trying to find the best possible solution, and for that I need to iterate all the possibilities, not just some good ones. I was triggered by the initial title of Free Blue and Brown's video, and this is why I'm making this live stream. And it seems that I can find the best strategy for 15% of the dictionary in around, I think it will be 2 minutes. Now what? I did pruning. I improved the constant factor a little bit. I don't think it helps very much to improve this further. I can implement that idea somebody suggested. If everything now splits into single groups, we don't need to actually consider those groups separately. So it will be some speed up. Maybe I should think about it as a graph, where given a group, I want to find a node, maybe one of them, that what? It has different colors of all the edges. One gigabyte, 4 seconds. 20 seconds to do 10% of dictionary, 300 seconds to do 15% of dictionary. So we're not there yet. I can do, estimating from this, I can only do at most 30% of dictionary in like one night. Different colors, yeah. If we have words S1, S2, S3, S4, what I was referring to about colored edges is that for every pair of strings, I can say what is the feedback if one of them is a hidden word and the other is my guess. The feedback is of course a string like green, yellow, black, 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 but I already assigned a number from 0 to 3 to 5th power, so a color like 50. Then every pair it has a color like that. And if a color is repeated like this, like 50, then this is maybe not the best guess, because you cannot distinguish between S2 and S5. Because if you guess S1, for both of those you get the same feedback. I would want to improve my pruning a little bit more, because this is where exponential factor comes from, at least like dictionary size to 6th power. Yes, I want to consider fewer possibilities, or maybe I should look at it as a graph and look for some kind of single best vertex, whatever that would mean. Oh, I was going to change this to a vector, but this map will often be very small, so I think it's not worth it. I can also sort this in linear time, but that shouldn't matter much. Compare to different strategies? Yes, you can compare to different strategies by running them for all the possible hidden words and checking, for example, measuring how many words on average it guesses, how many guesses it does. I wonder now what is the pessimistic case for my algorithm. I guess, can I just print max ID? Not really, because I try all the possibilities. I would need to implement more code to print statistics about this best solution I found, and for now I'm too lazy to do it. What else? I wonder if caching helps a lot or not. (0.63). Here it doesn't help and only increases the memory. So let's try for bigger data. Dictionary size is 10%. No, 10% will take too much time. 8%. Without caching and with caching. An ordered map versus map. If the time complexity is exponential, we shouldn't care about any logarithms. Also, I shouldn't really say exponential this whole time. It's not exponential, it's polynomial, just with big exponent. This is so caching version is slightly faster, just slightly. I guess thanks to pruning, we anyway got rid of many states. But at least it means it doesn't seem to be a big problem to run it without caching if I'm worried about memory. I think I'm spending too much time running my program again and again to see some statistics, but this is simply because I don't have a very good idea on what to implement next. I can solve the problem for dictionary of size maybe 2000. I don't think that my map is now the bottleneck of my solution. $140 megabytes and 35 seconds versus almost nothing and 41 seconds. So yeah, map helps just a little bit. What else? Let's try this single thing. If everything is single, then this is the best guess. So what? I think it means exactly that after going down, we can break. This is not good test for testing because it takes so much time. One version, and then without that, wait, wasn't I supposed to break here? Okay. Second version, is the answer the same? Yes, and the time is very different. It's like 1/4 better, so then I'm going to here already there, if all single, I'm going to detect the answer, and I believe that I'm not adding anything more. So what about this? It's scary, but I think it's correct. Didn't change much. Just to make sure, if I remove that, the time will become around 3 seconds, right? Well, 2.65, so maybe the difference isn't that big. Even more, in this case, should I really make a map? Maybe I should first check if this is possible. This should be very common for small groups, and then I will not go into leaves. It makes sense that it is a speed up. But can I avoid a map? Okay, now what I'm doing right now is very ugly. Don't try it at home. And I'm not even going to explain it. This is a very, very ugly hack. Slightly faster. Can you make a video about this code? I'm going to. Did you get inspired by Free Blue and Brown? Yes. More like triggered. You can say inspired. What else? I can maybe iterate all the guesses, do this, and then go again? Question mark? So repeat twice. The first time you will do this. And only the second time you will continue. That's not right. For both turns, if done then break. Otherwise for every guess. Which might be an issue. Too small of a difference to rely on that, so I'm Ctrl-Zing this because I wasn't sure about the correctness. Okay, what next? Given a small group of words, if one of them, if I can ask about something so that they could all be distinguished, then this is a good move and I don't need to consider further. And that should happen a lot. But still a big issue is just the number, this almost exponential number of cases. Version control system, I agree. I agree that I should I don't like doing that on a stream, for example, because if I am to type my password, I can mess something up and actually show you my password. Yes, of course, I can do something not to need to type the password, but I also would need to do that. Local git repo. I would then prefer the normal repo, but I'm just not used to doing that, and I'm stupid and don't want to try. Please make AI like human brain. I don't think that a human can play this optimally. Do I need this? Or does that help? Well, let's check if it helps. 2.3, right? 2.3. Doesn't help, but this is needed, right? Not really. Because I guess very quickly we get down here, so, but doesn't hurt to leave it here. Oh, and it would be cached early on. And what else? You can do a small improvement there. Not to search in the map twice. What do you want? Oh, 2.56. Okay, that was just a fluctuation. Alpha 0 may help picking the right order of tree traversal to maximize the pruning. Oh, that's meta. Use some smart AI just to give me a better order of my pruning, even though I'm not using AI. What's the progress I just rejoined? I think the progress is nice. I'm able to, even for the full dictionary, I would be able to consider one first candidate, thanks to very nice pruning. So, in less than a year, it would finish, I think. Gupta, it seems that you typed something and it's first part of a message. I don't know if somebody already tried it, but I recall someone suggesting it in the chat. Suggesting what? Using AI to find better order for pruning. It's almost 4 hours, so I will soon finish for today. I will try for at most half an hour more, and that's it. And if so, I will just continue tomorrow evening, same time, with more ideas. You need to remember, machine learning isn't really fast. Algorithms are much faster than machine learning. Machine learning can find some kind of patterns, but it's not that in a faster way it will iterate an array or all subsets. Yes, I will put the code on GitHub. If somebody is now joining at this moment, they will have a lot of fun guessing what I'm doing. $200 viewers for like the whole stream. That's very nice. I guess Wordle is a well-known topic. For large sets, Better guesses are fairly obvious. Yes, we don't need anything smart to identify them for small sets. But small sets are anyway fast. Even if, let's consider that I have now an amazing tool that allows me, if set size is at most 30, then in just one operation I can solve it. I claim that it doesn't help that much, because I already have almost exponential number of ways of getting from the start to those small sets, and that's something where pruning helps. And when we tried smaller sizes of dictionary, the improvements I found was ×2, stuff like that. For a big dictionary, it might be ×100. When this is a constant improvement, like maybe ×10, and that's it. When we are talking about exponential stuff, changing an ordered map to map or changing values representation, it's a constant speed up, not related to exponential branching. So it's always worse. Pruning is always better, assuming that it really prunes stuff. Chat, any ideas? So what is it right now for just one candidate? That might be interesting. I will try best 5 or whatever and worst 5 candidates. Too much. Assuming that we started from few very good candidates, is it true that when we get to bad candidates they will be handled fast? Yes, that's true. That's a very good information. Where this was terrible. You remember how I ran it for Gami, for big dictionary? Then it was almost like we ran again for the full dictionary. And it needed gigabytes, and I was scared about my computer. Here it's great. 17 megabytes. Do I even use cache? Oh, I don't use cache. That's stupid. To test something and then not move it back. 17 and 19.2. 17 and 19.2, also this speed. Twice faster, the answer is the same, more memory. All right. This is top and bottom 1% of candidates. Let's try fewer candidates, but bigger dictionary. And I don't think I will implement anything more today. It's just now about running it for as big dictionary as I can. And when I print this, I want to also print the real string represented. Yes, I will make a video. Oh, I'm not going to use that as a part of proof, the fact that I use first canned ratio. This is just for fun, so that I could see how slow my program is for big dictionaries. We don't have proof, because that's also not true, for the fact that I only use words among the existing dictionary, not all the words, and that will be like maybe times 100 slowdown. But it's not a big deal. Interesting, it seems that for this bad candidate we were quite fast, but now there is a new one for which we are very, very slow. Okay, let's get back to something I started doing at the beginning. I want a list of words that are possible answers in Wordle, and I think there is only a list of 2000 words. I want to run my program for all of them. I want to solve for those, because 2000 is like 20% of my current dictionary, so it should be viable. Okay, 20 more minutes and the stream will finish. I should do streams more often, but not for such a long period. Again, there is some string now where the program seems stuck on it. It is very slow. And I guess it is a string full of very uncommon characters. Yeah. Notice how it has repetitions. It's A, J, Q. How am I currently looking at those when sorting? Well, it's one of the worst few, so yeah, Bobby, Faffy. But still, it's interesting that that was slower than Faffy. Maybe it's just about the order and how pruning works in that case. Oh, there is this list of 2300 words. Thank you. Let me use that. So those should be very common words. There is, let's call it, I don't know, into txt, paste it, 2300 words. Where do I read? Here. Into txt, and this time pushback s. Crazy fast, obviously. Okay, I think that my program, we can run this program now for several minutes to work for everything in this dictionary, and this will be close to an optimal guess. Let's try full ratio. For now, just 1% of coordinates from both sides, top and bottom. Yeah, it's nicely fast. Here Slate is the best. 50 megabytes, 10 seconds. Yes, that's reasonable. Now I did 2% in total times 50. It should take 500 seconds. Good enough for me. Oh, no. I want to here say everybody. Given this dictionary of 2300 words, so those, including lager, issue, phony, gassy, trial, I think we can find the best strategy with one but. But I only allow asking for a word that is still a possible word, that is still not in contradiction with previous feedbacks. Are you still up to online classes? Yes. You can go to this page to read about it. I guess it will be frustrating on YouTube when I don't display the chat, but also I'm referring to something I've just typed in the chat. Snark News Winter Series this year. No, but I'm participating in Petrozavodsk. We're halfway there. Nice. I didn't respond. If I didn't respond, it's most likely because I didn't read the email. And related to that is, since the Twitch hack, the Twitch leak, I get so much spam. People, it's like registration to porn sites. It's very annoying. So my, let's say, business email got spammed thanks to Twitch. Only using words that are possible candidates is even harder than Wordle hard mode. Yes, harder, but easier for an algorithm. Do we even see here something that program got to the end, like without pruning earlier? Not really. So I'm almost certain. Oh, diary got a result, which is not infinity. That's an achievement. We should here have 2300 words, so we are getting there. Should I spam too? No, just write an email and wait. I will stream tomorrow again. Maybe first I will refactor this even more. Also, I will read it to check that there are no mistakes. Maybe there was some improvement that now I commented out, like all single, but I think all single happens somewhere. Right? Why am I looking at this code? Oof, I should look at this code. I thought that I'm modifying the wrong code for the whole time. I have 300 lines, so it's not that bad. I can remove that, I believe. What about guesses outside of the remaining range? If group size is big, it isn't a big difference. If group size is small, it's a huge deal. But maybe I should hope that most of the time this will work. Maybe there is some heuristic that says, maybe it's possible to prove this. You need to always make such a guess that you will split the words into two halves at least. By halves I mean, if right now there are 100 possible words, maybe we can prove that then after my guess right now, at most 50 words will be possible. If I can prove something like that, it will help a lot with speed. Okay. 1 gigabyte, 5 minutes, and the answer is slate. That's for a dictionary of 2300 words. those that are actually possible answers in Wordle. So if we use this dictionary, this is the average number of guesses you can get. Maybe we can do a little bit better thanks to words outside of this. And this was really all the things in dictionary. What about this? I will get half of this dictionary, get only some part of the candidates, but I will actually allow guessing outside of the range. So in dictionary. Will that slow things down a lot? Not dictionary, it should be the all the possible guesses, but for sure I want to guarantee that the map size is at least 2. That's actually split into some cases. If this is equal to remaining that size. What can you tell me about that? Something is wrong. I got to 4 gigabytes. Maybe some infinite recursion or something like that. Let's try very, very small dictionary. No, not full one. Why am I printing 1%? Oh, it's 1%. I thought it's 99%. Okay. Is this an infinite loop? Yes, it is an infinite loop. Why? For every guess, I don't care about that. Maybe I do care about that. Still bad. If the size of the map is equal to remaining size. This seems right. I'm stuck at 3. Why? Then I iterate over all possible guesses in the dictionary, which is something I don't use. And apparently I go down into something with also size 3. If size of this map is 1, then it means that everything is the same. It's of course much slower, but I guess we can improve that a little bit. So for the very first time, because I'm iterating now all the words, for this dictionary of size 500 or so, this is the optimal strategy. That was 6 seconds. Let's try half of it. And now there is no but. This is the optimal strategy. For now it will be around 1000 words. If I want to speed this up, I need to iterate. Maybe first I should iterate the remaining stuff, because very often I will break from that. Only then the rest of dictionary. Yes, I think it's a good idea. This should be faster version of this code. Both of them need to get to 1000. It doesn't seem that this is much faster. There is still but of allowing guesses outside of remaining words, but I've just fixed that. This is the change I did a minute ago. I mean, it's not now. This is not a full dictionary, but given some dictionary of allowed words, my program is now correct. Just of course slow. What else can I improve? I think I will get rid of this map, but no, I'm optimizing constant factor. I should improve pruning and now this thing, because that's a big deal. Is it possible to quickly recap the algo? I think that the stream will end now, or actually when we get to 1000 words here. So it's a good time to finish and recap the algorithm, which is not a very complicated one. I didn't go above 300 lines of code. And I didn't do anything very complicated. I think I wasted too much time running things, but I just didn't have better ideas. So here's the summary and some kind of recap what I'm doing. Right now my program only is fast enough if we give it a dictionary of like 1000 words. For a dictionary of 10,000 words is just way too slow, but we will work on that tomorrow. So what's the recap? I iterate over the first word that I can guess out of all the words in dictionary. So there is some initial state, the empty one, there is nothing. Then I decide to ask about maybe abaca, maybe laser, or maybe many other words. I consider all of them. For testing purposes, I also sometimes only tried few of them just to see if something works better. Then, what happens once I ask about, for example, abaca? There are multiple possibilities of what I get as a feedback. green, yellow, black, 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 for example. Depending on that, there is some set of remaining words possible. S1, S2, S3, so on. Words that are consistent with this feedback. This is one set, this is another set, and so on. In each of those possibilities of feedback, I get, let's call it set 1, set 2 of strings, set 3, set 4. S here doesn't represent string, it represents a set. So those are, for example, 50 different words that are still the answer. And now, just like I hear from at the top, I have a choice of what word I am asking about. All of that I do in recursion, and I iterate all the possibilities of what is my next query. This way I basically iterate all the strategies. But this would be extremely slow at every layer, at every new node of this recursion tree to try linear number of strings, because in total that's exponential. So I have some speedups, like in any DP, recursive DP, memoization or cache. I also have various types of pruning, where if I now consider after laser here some word like gummy, and I see already that laser had expected value of, so the number of guesses on average equal to 3.5. If for gummy I already exceed 3.5, then I stop and I don't finish considering gummy because I know it's not optimal. So with pruning, just like there is alpha beta pruning in two-player games, I'm able to speed things up. Still, my algorithm isn't linear or quadratic, it's much slower, but for dictionary size around 1000, it is fast enough to run in a few minutes. I guess we can close this and focus on that. My program took 70 megabytes and less than 4 minutes when running on dictionary of size 2300 divided by 2. Is it close to 24? No, 2300. So around 1200. I can now estimate that if dictionary of size 1200 takes what? 4 minutes, then I think for 2300, so the full dictionary of words that are possible answers in Wordle, I will need around, I think, 30 minutes. Hard to say, maybe it's 1 hour. And if I want to run it for 12,000, I still estimate it as 1 year. But now I'm more confident that it will be computed in 1 year. We can introduce parallel running if memory allows that. So using, for example, AWS and like 100 nodes, which is something I might want to do. Let's quickly verify this. If I decrease this twice from 200 seconds, what do I get? Five seconds. So times 2 increased it by times 60. Oh, that's bad. That's very bad. So it's more like 4 hours. But then 5000, it's more like this times 60 again, that's like 10 days. So 10,000 should be 600 days. So maybe more like 5 years. But divided by 100 machines, if I run it in parallel, that's less than that. That's less than 1 month. Like 2 weeks. Great. I really want to solve this. And again, only few candidates are reasonable. And we can say with certainty that one of them is the best first move, and then it's easy to consider that. But I am going to prove that this is an optimal strategy, and for this I need to go through everything. Just like you would try to find an optimal strategy in chess. It's not enough to just consider some opening moves. You need to analyze all of them, because maybe one of them is a counter to your strategy. That's not true. true anymore. Tomorrow, same time, refactoring and some optimization here. Maybe I will try to write this in parallel, which is easy here. I will forget about cache and try various first words separately. Just they would need to share this first. The expected value that I know is possible should be given once for all those machines, which is fine. Yeah, we can talk about that tomorrow. Thank you everybody for following me. I need to maybe tomorrow morning check my email. This is my answer to those people who ask me, I messaged you but you didn't reply. Sorry, I get a lot of spam, a lot of messages. Thank you everybody for watching. Again, if you want to join my paid classes for competitive programming or lead code or also Olympiads, then check out this link, erichta.com/classes. And I'll see you all tomorrow. Also, you can check out the Discord server, which I'm not really active there right now. It's always like when I have a lot of time, first I make YouTube videos, Twitch live streams, then if I have even more time, I open Discord. So in past few months, I wasn't on Discord for a lot of time. Sorry about that. But, well, what can you do? A day is only 24 hours and you need to sleep. Thank you for watching. Bye.